Yes, student, next one, oxides of 17th group elements. Okay, almost all the elements of 17th group, that is halogen, can form the oxides with the oxygen, but their oxides are very limited. Like fluorine, okay, is very small in size, so form only what? Two oxides. What? OF2, oxygen difluoride, and O2F2. It is because oxygen can show only one oxidation state, which is -1. Therefore, it cannot combine with a large number of oxygen. Moreover, its size is so small that it is unable to form, okay, the oxides with larger number of oxygen. But in the case of chlorine, chlorine can form OCl2, that is dichlorooxide, or oxygen dichloride. It can also form ClO3, can also form Cl2O6, and one more compound is there, Cl2O7. Rest of the compound can also form dioxide and trioxides. Student, here very important thing, like here OF2 structure is just similar to OH2. Okay, OH2, that is simply what? You can call it water. Besides of writing H2O, I have written what? OH2. It is because it is OF2. So they are having the same structure. How it is same structure? In water, oxygen has two lone pair, okay, and two bond pair. So it has what? Bent shaped structure. Similarly, in the case of OF2, again the oxygen is a center atom. Fluorine is again very small in atomic size. Along with the two lone pairs are present. However, bond angle in OF2 is little lesser. Okay, water. But the question is what? Bond angle in OF2 is lesser. What is it? 103 as compared to what? H2O, which has 104.5 degree. Now the reason is what? Actually, reason is that oxygen is more electronegative as compared to hydrogen. Therefore, the bond pair electrons are slightly shifted towards oxygen. Thus, electron density in the oxygen is very high. Therefore, electron repulsion is very high. Due to very high electron repulsion, the bond angle become 104.5 degree. But student, in the case of OF2, now I told you earlier, the fluorine is the most electronegative element. Thus, the bond pair is getting shifted towards fluorine from the oxygen. That means the opposite effect takes place here. And due to this opposite effect and the higher bond length, the bond repulsion is lesser. Means what? Now the bond pair electrons are shifted towards fluorine. That is, it goes away from the oxygen, and being it goes away from the oxygen, therefore the bond pair repulsion is little lesser. Therefore, the bond angle remains only what? 103 degree. Students, similarly, one more molecule you can discuss, OCl2. Now in OCl2, the bond length is higher, okay, and the electronegativity of oxygen is more. That means what? Here the shifting of bond pair is shifted very less, and therefore the bond angle in the case of OCl2. Okay, now OCl2 means what? In case of OCl2, you can check here, the bond angle will getting what? Increase. Why it is getting increase? It is because bond length increases and the shifting of electron do not take place. Thus, the bond angle become 111 degree. Okay, that is, it is very interesting phenomenon. The structures are same, that is having the bent structure. However, there are different type of bond angle. So this is about the bond angle. Okay, now the preparation of OF2. It is very specific compound, so we can deal it when sodium hydroxide and the fluorine reacts. It forms OF2 plus NaF plus H2O. It is very specific compound. Okay, similarly student, if you will discuss the next one, what O2F2, the structure of O2F2 will be quite similar to the structure of H2O2, like what? Open book structure. Okay, like say O, this is O, this is F, and this is what? One more F. Okay, so the OF2 structure is similar to OH2, while O2F2 structure is similar to H2O2. Student, besides of it, we can deal in this video. Okay.